Okay, so Leetcode practice time. Two goals in this video. The first one is to find the specific solution for this programming question and put in some solid code. And the other goal is to see how to behave during a real interview properly by following the process in a coding interview. So let's get started. So remember, always in a coding interview, the first step is to try to understand the problem. What the problem is asking us to do, what kind of problem is it asking us to solve, and if there's anything unclear, so try to ask some clarification questions to the interviewer. And at the same time, think about the edge cases, which could be special in processing, like in coding. So let's read through this problem. Serialize and deserialize binary tree. So serialization is a process of converting a data structure or object into a sequence of bits so that it can be stored in a file or a memory buffer, or transmitted across a network connection link to be reconstructed later in the same or other computer environment. So design an algorithm to serialize and deserialize a binary tree. There's no restriction on how your serialization or deserialization algorithm should work, and you should need to ensure that a binary tree can be serialized to a string and the string can be deserialized to the original tree structure. Alright, so the input or output format is the same as how Leetcode serialize a binary tree, and you don't necessarily need to follow this format, so please be creative and come up with different approaches yourself. Okay, so let's take a look. Example like this, input will be a tree, something like this, and output is that as well after we serialize and then deserialize. So I think we are pretty clear about what the question is asking us to do. Let's see. So the constraints is that the number of nodes in the tree is in the range of 0 to 10,000. Alright, so it could be an empty tree. So potentially we may think that the empty tree is a edge case, and the node value is between -1000 to 1000. Okay, so now I think we are pretty clear about what the question is asking us to do. The next step is to find the solution. So finding solution, so how to solve this problem. So of course, we can always use the pre-order traversal to store the tree into the string. So for example, for this input example 1, for this we are going to do a pre-order traversal. First visit root, then left subtree, and then right subtree, and then we store it into using a string, and the string is separated, and each node is separated by a comma. I think that should be able to solve the problem. And at this time, we are not only going to it's not like we are only going to store the nodes that are not none. So instead, for example, for this subtree, we are going to store something like 1, 2, and none, then none, then 3, then 4, then none, none, then 5, none, and none. So in this case, we are going to visit the left subtree and the right subtree. Suppose the node is not none, and in this way we can know whether the node is a leaf node when we try to deserialize it from the string. So I would say the runtime for this approach is gonna be linear to the number of the nodes within the tree, and deserialization, similarly, the runtime is going to be linear to the number of the linear to the number of the nodes within the tree. So let's get started and do some coding work. So after you discuss the solution with your interviewer and you get an agreement about the solution, then the next part is about putting in some code. So here we care about your code correctness, your code readability, and also don't be too slow about coding. So let's get started. So for serialization, first of all, we will put something which is a string serialized tree. Okay, so I actually don't need to do that because the serialize is going to return the string, and the serialized tree will be the input for deserialized function. So we don't need that member to store that. So let's see how to do that. So we are going to do DFS in outer traversal of the tree. So let's see. If equal to none, then what we are going to do is we are going to so here we just need to return none, or we can so we can actually define some other helper function. Let's say string serialize. Let's overload this function tree node with root and the partial string as serialized tree. Okay. And then you say in this private function, helper function, you're going to say, okay, if root is equal to a non-pointer, then we will return none. Let's see if we should add a comma here. I think we should. Yes, we should. And otherwise, we need to serialized tree. So return this one. Serialized tree plus equal to let's say root dot value I think integer dot to string, right? Yeah, integer dot to string root dot value. Yes, plus the comma here. So this is the root node we have visited. Then serialized tree plus equal to serialize what is that? It should be root. So actually, why should we pass the serialized tree here? So we don't actually need this one. I think let's say serialized helper. Let's say serialized helper. So instead, we are going to first define the serialized tree as empty thing, and do we really need that? So if we don't do that, then yeah, it is actually just the partial string. I think that's what we wanted. So it's a left and the serialize g plus equal to serialize helper, and then root dot right. Okay, alright, and finally we will return serialized tree. And then in here we just call serialize helper. Serialize helper. So actually, why do we need the serialize helper? Since, yeah, that's a good question. So we don't really need the serialize helper here. So instead, it's just a serialize. Okay. So that's the serialize function. So serialize if really is equal to none, then exit of the recursion. Otherwise, if it's not equal to none, then we first visit the root node, and then the left subtree, and then the right subtree. Alright, so let's see the deserialization. So for the deserialization, first of all, we are going to split it. Let's say string node array is equal to data.split using the comma, and then what should we do? So actually we can use a list of the string, let's say node list as new linked list of the string, and this one we will say okay, node AR, I think it's arrays dot to list. Let's see how to so array to list in Java. I think there should be some helper function there. So converting to array. So okay, arrays dot as list dot as list. So it's arrays dot as list. Alright, so okay, so it's not like that. It's just as list. It's node AR. Okay. And then we are going to try to do some pre-order traversal. Similarly, pre-order traversal to deserialize it. So this one, let's define a deserialize helper.
I didn't get that.
Helper. So this one we are going to pass in a list of the string node list, right? So first of all, it's a root node. So if node list, so actually we should say, alright, so string node wow is equal to node list dot get, or just first, is there any first thing? So okay, just get 0, and then we are going to remove the first thing, remove the first thing from the list, and node if node list dot if node value is equal to equals a none, then pretty much we just need to return a none pointer for it. Otherwise, what we need to do is we need to have the tree node is equal to new tree node as integer dot from dot value of dot value of the node value, okay, and then node dot left is equal to deserialize helper and the rest of the node list, and similarly we are going to do the right thing, okay, and finally we will return the node, and then here we just call deserialize helper on this node list, and we just return the return value of this helper function. Alright, so I think that's pretty much it. Remember, the last step after coding is about testing. Always do testing after coding. So the first step of testing is to explain how this piece of code is gonna work by doing some sanity check with a simple example. So let's see for this one. So serialize, if it's none, then we return this one, but root is not equal to none, so currently we are going to say, okay, serialized tree is empty, and then serialized tree is going to be something like 1 and a comma, and then we visit the serialize on the left subtree. So the left subtree is going to get us so first of all is 2 for sure, and then comma, and then the left is none, so it's going to return none, and then none apply to it. So this is the left subtree, so it is going to now it is going after the serialize on the left subtree returns, the string would be something like this. And then we are going to call the right subtree. So on the right subtree, similarly, it is going to return something like 3, and then 4, none, none, 5, none, none. And after this one is returned, it's append to the end of the tree. It's the end of the serialized tree. So now we are going to return this one. So you may have noticed that that there is the suffix comma within the serialized string, but it doesn't really matter actually. So yeah, it doesn't really matter. So let's see the deserialize helper. So I will explain why it doesn't matter. That is because for this deserialize helper, it is going to be pre-order. So when it encounters the last none, it has already constructed the last node of the tree. So this one, the empty thing, will not be used. So here, let's see. First, so for the let's see if we want to deserialize it, how is it gonna work? So first of all, it's going to split using the comma and get a list of it, and the list would contain 1, 2, none, none, 3, 4, none, none, 5, none, none, and another empty thing. And then we call deserialize on this node list. So first of all, we get the first element, which is a root. We will have 1, and then we will call deserialize helper on the node list again. So currently the first element is 2. So the root of the left subtree is 2. And similarly, we construct the left subtree elect the left subtree by calling the deserialize helper again, getting the non-left child and the non-right child. And that's the end when we construct the left subtree, and similarly for the right subtree. So I think it should be good. Let's give it a shot. Okay, so it's accepted, and let's submit. Alright, so I think it looks good to me now, and it looks good to the system as well. So remember, for the testing, after sanity check, try to introduce some test cases so that it can have good enough test coverage. So for example, I would say a empty tree would be something worse to test on, and something like example 1, which is more general tree. I would say example 1 and 2 should have good enough test coverage. And yeah, sure. So I think that's it for this coding question. So if you find it a bit helpful, please give me a thumb up, and I'll see you next time. Thanks for watching.